Hello guys, in this video we're gonna learn something new, which is how to convert from delta to Y. What is delta and what is Y? These are types of connections that you can connect, your resistances with. So, for example, in this video we're gonna learn how to convert from delta to Y, and in the next video we're gonna learn how to convert from Y to delta. So, what is Y? What is delta? Delta basically is this connection here. It is very similar to a triangle shape. So whenever you see your resistances make a triangle like that, you must think of like a delta connection. And one thing to note here is that these resistance are not in series. I mean, RA, RB, RC are not in series. I mean, this is a sub-circuit. I mean, there is some connection here, there is some connection here, there is some connection here, but I didn't draw. If RB and RC in series, for example, then there is no need to learn the delta, you can just add them together. Okay? So whenever you see this sub-circuit and they are not in series, this is basically a delta connection. And usually when you convert the delta connection to Y connection, the problem becomes solvable. Very easy, and you can get the equivalent resistance in a very easy way. So what is Y now? Y is the other side of the story, the other side of the coin. Okay, so it is basically a connection that is very similar to the letter Y in English. Okay, although here it's upside down. Usually we draw Y like that, but it is basically drawn or basically in this case here it's upside down, so it is like that. But in any case, in in uh, in circuits, we don't care about geometry. We care about connections and terminals. Okay? So that's basically the Y. So how to convert from delta to Y? Okay? So as you notice here, there are three terminals. Number one, number two, and number three. So if you have, a delta connection like that between the same terminals, one, two, three, between exactly the same terminals, you can create this Y connection. And you're gonna have a new terminal that you created by this by this conversion that it wasn't there before. That's a new terminal. Okay. So you're gonna take these corners of the triangle or the delta and keep them the same. And between the same terminals, you're gonna draw or have a new connection R1, R2, R3. Now, how to calculate R1, R2, R3? I put here the equations. Okay, it's very easy. So you have to note that the denominator is always the same. The summation of all the resistance is the delta connection. Look, guys, RA, RB, RC, RA plus RB plus RC, RA plus RB plus RC. So the denominator, is memorizable. You can memorize it very easily. Now, how to get the numerator in each one of the equations? Look at where R1 or R2, R3 is connected, you're gonna know. Okay, so let's start by R1, for example. R1 is connected between RA and RB. So this is R1 here. It will be connected to the same terminal that was connecting RB and this terminal number one. So it is going down from this terminal, the terminal that was connecting RA and RB. So it is between RA and RB. That's why you're gonna see here in the numerator RA multiplied by RB. How about R2? R2 is connected to the terminal number 2, which is between RA and RC. That's why in the numerator here you have RA multiplied by RC. How about R3 with the same concept? This is R3 now. It is between RB and RC. That's why in the numerator you have RB multiplied by RC. Let's have an example to see how beautiful and how strong this concept is, and to make your problem so easy to solve. So in that circuit here, it asks you to find the R equivalent between this terminal and this terminal. And believe me, it is so hard. If you don't know how to convert from delta to Y or from Y to delta, it's so hard, extremely hard. Okay? Maybe unsolvable, actually. So let's search now For I give you the key to solve it. Basically, we're gonna search for a delta and convert it to y. Sometimes I call y star because this is how we learn in Egypt. We call y the star connection. It is the same, okay? But it should be named y because it's very similar to y. So we have actually here two deltas, okay? There is a delta in that mesh, and there is another delta in that mesh. So I'm gonna leave one for you, so you should solve. I'm gonna convert one of the deltas into y now, and find R equivalent. And as exercise for you, try to solve with the other delta, not the one that I did. You should get exactly the same R equivalent. Okay, so I'm gonna do this for this loop number 2, and I'm gonna leave you this loop. Okay, so let's do that together. What I'm gonna do, I'm gonna copy and paste because I'm gonna do something fancy here before I continue solving, because I want you to imagine, this conversion very well. Okay, so this is basically the same. I just copied and pasted. Okay, I'm gonna omit 6. 6 is connected between this terminal and this terminal, correct? So I'm gonna, modify the drawing. So I'm gonna draw this 6 ohm like that. I didn't change anything. We don't care about geometry in electric circuit. We only cares about connections. And still, 6 is connected to 18 and the 18 on the side. The other 6 ohms, I'm going to do the same for it. So this 6 ohms connected to this terminal here. So I'm going to modify the drawing a little bit. Now you believe 100%, this is a delta, correct? It was delta, of course, before. This is just an extra step to make you feel it, but you can just, start directly with that circuit in here. Okay? Good. So we have now a delta. So let's now draw the Y connection, the conversion, because we're going to convert this. So this is R1. This is R2. I'm going to draw them with different colors so it become clear for you. And this is R3. Let's start by R1. R1 is between the 6 ohm and the 6 ohm. So 6 multiplied by 6 divided by the summation of all the resistances in the delta connection. We have 3 resistances, 6 plus 6 plus 18. Okay? You can do this very quick. I'm going to use my calculator here. So 6 multiplied by 6 divided by 6 plus 18. That's 1.2 ohms. How about R2? It's a green one. It is between the 6 ohm and the 18 ohm. So 6 multiplied by 18 and same denominator, 6 plus 18. Let's do that very quick here. 6 multiplied by 18, 3.6 ohms. And this is actually R3 as well, because R3 is between 6 ohm and 18 ohms. So 6 multiplied by 18 over the same denominator. So it will be equal to R2, 3.6 ohms. And look now at the beauty of converting from delta to Y. You can just omit the delta connection. So basically, this is what I'm gonna do. Gonna take eraser here and just erase the 6 ohm completely. Remove the 6 ohm also. And remove this 18 ohm. And we're gonna end up with our new created basically resistances R1, R2, R3. Let's even put the values. So R1 is 1.2, R2 and R3 3.6. And let's now look at the circuit after this conversion. You're gonna see that the 18 ohm and the 3.6 are in series, correct? So you have here 18 plus 3.6, it's 21.6. In the middle branch, you have the 6 ohm series with 1.2. So in the middle branch here, you're gonna have 7.2. And in the bottom branch, you have the 9 ohm series with 3.6. You have the same current. So that's basically 12.6. I might have like, so let's continue with white here. Look, guys, this point here is basically this. But I just elongate this wire, okay? Again, any short circuit, we don't care about its length. In our circuit, a short circuit like that, you can draw it very long or very short or even a point. Okay? And we continue with the rest of the circuit. You have here the 1 ohm. You have here the 18 ohm. And this is the two terminals. Good. Now look at that. Look at that. The 7.2 and the 21.6 are in parallel. Why? Because they have the same terminal. So same terminal here, same right terminal, and same left terminal. So they are in parallel. Okay? So let's calculate that very quick. So you guys use the calculator that I leave in the description. You know it. Just watch my former videos. I can even show it to you. So let's show. Yeah, let's do this together. Okay, here it is. So this is the calculator that I'm using to calculate the equivalent resistance of parallel resistors. Okay, so we have here two resistors. So two. This first one is 21.6. The second one 7.2. And just click calculate 5.4. Okay, so we can just redraw this 5.4, 12.6, 18, then 1 ohm, and this is basically what we want. Okay, good. Now look at that. The 5.4 and 12.6 are in series, so we can combine them in one resistance. 5.4 plus 12.6. That's 18. So that's basically the 5.4 and 12.6. It's one resistance now. 18. And here is 18. And this is 1 ohm. Oh, now the 18 and the 18 are in parallel. Okay, so, and they are equal. So the equivalent resistance will be divided by 2. So that's basically will be like that. The 1 ohm. And you have here 9 ohm. So our equivalent becomes so easy now. It's 1 ohm plus 9 ohm, which is 10 ohm. Okay, guys, that was it. Thank you very much for watching and see you in another video. Bye-bye.